Κυρίες και κύριοι, ο κύριος Μαχντάβη.
Ladies and gentlemen, it has been a long day. I hope you have still the cognitive capability to follow me. I will try to make it compact. I will talk about a subject which has some technical ramifications, but I would like to also maybe put some ideas on the table which may be a little bit unconventional as we talk about this phenomenon. If I ask typically people, my students, what is the associations with so-called green architecture or sustainable architecture, or generally about issues of energy efficiency in buildings, typically these type of images emerge. But the reality is that the issue of energy efficiency really cannot be captured, cannot also be dealt with in terms of single-standing, so to speak, alone solipsist buildings. Fact of the matter is that since about maybe 10 years ago, more than half of the population of the world is living in the cities, and in a generation it will be 2/3. So that is the reality of the built environment that we are dealing with, and any aspect that we are talking about in the environment, energy efficiency, building quality, and whatever has to be in this context, has to take this context seriously. Like to talk about maybe 3 M's with regard to this urban environment that we can think a little bit about, reflect about. One issue is the physical constitution of the urban environment. In many cases in Europe, we have a heritage. A large percentage of our buildings, so to speak, are very old. They constitute a certain morphology, which is there, has a certain persistence. But something that we almost never talk about is the second M, which is the mobility. Not heard a single word about that, is a feature of the urban context which has major ramifications about the energy efficiency of the total built environment, far and beyond the energy efficiency of individual buildings. It is an uncomfortable issue. It involves policy issues, lifestyle issues, and it's not being addressed. But at some point, the building community has to also get a grasp of it and has to address that, because the interface between the urban design and the energy efficiency has this mediating effect of the transportation systems. And finally, the microclimate, which is the real part of my talk. As to the morphology, we could discuss that a lot, but I just would like to draw your attention to a very simple fact. The more dense urban context, the less the energy consumption. The less dense you make the urban environment, typically in the US cities, the average energy consumption is higher. It's almost like a natural law. It's very clear. A dense urban context, independent of the quality of the buildings, has a major impact on the total environment. So the morphology is an important issue. Urban development project issues are important also in the third world, something that, again, get forgotten a lot when we talk about technology featureism. We talk about things that you can attach to the building or put on top of the buildings, and forget about the fact that the urban growth, if it's not within a certain, so to speak, morphological constraint, would create energy issues that we cannot solve. I talk about mobility. Just think about the space that you need in the urban realm for pedestrians. This is drawn to scale for bikes, for buses that are about 40% occupied, or for cars. The individual transportation system, very dominant, increasingly dominant in developing countries. In Europe, we hope that we can kind of have passed over the period where we have been dominated, so to speak, by the individual transportation in our transportation systems. We talked about this a little bit today, but I think it's important to understand here, just as a demonstration, I take a typical Viennese urban dweller, a kind of middle class, and I look at the kilowatt hours energy that this typical urban dweller has for the building. For the buildings, if we would make them all passive standards, for a typical driving habit, 25 kilometers per day, believe me, Viennese drive more than that. If a person would do 1 transatlantic flight every 2 years, and this is the typical gadgets that we all use, from the hi-fi system to the cellular phones and so on and so forth. This is the total average, so to speak, for this typical Viennese over these activities. So this is, if you would take all the buildings in Vienna from the current to the passive standard. And this is the solar collection potential if we had every Viennese them 5 square meters of solar panels. So these orders of magnitude gets close. We can maybe start talk about a very extended definition of zero energy buildings, but we would have to address issues of storage, seasonal storage, and other issues. Otherwise, the discussion remains at the level of futurism, technological futurism, without a lot of depth to it, really. Now, getting closer a little bit to what I'm supposed to talk to you about today, which is the urban macroclimate. It was alluded to before that generally we don't talk about urban macroclimate per se. We have the issue of macroclimate change. We have been aware of that, at least in theory, we have been addressing that. This is, for example, an early study done by one of my students some time ago, looking at the thermal performance of various typologies of the buildings, and just envisioning if the climate expressed in terms of the increase of cooling degree hours, what ramification it would have for the cooling energy increase. I think Dr. Rollin mentioned that the increase of cooling load will become a major problem as an implication of the climate change, and that is very true. You can see orders of magnitude of 100, 200%, but for example, by changes of cooling degree hours in about 100 to 150%. We have been looking beyond the notion of climate change, just also at the interesting features of the urban macroclimate per se. Many of you are energy specialists, maybe you do simulations, for example, and your energy boundary conditions for this type of modeling is a kind of a weather file, standard reference weather file. But typically the data that are constituting those type of weather files coming from some weather station somewhere at the airport or whatever. The issue is that the urban macroclimate is much more interesting and much more complex than that, and it's affected by a number of factors, which we can talk a little bit about that. Just to provide you with a flavor of that is an example, we have a mobile, so to speak, macro stations that our students, as part of their training, kind of use to go around the city and try to figure out what is the macroclimate in the city. And here is just one example of the type of variance that you see for the same period of time in areas that are fairly close. These are no more than 1 kilometer apart. And nonetheless, you see temperature ranges about 3 Kelvin differences depending on the locations and the specific features of that location. Be that, for example, presence of trees, presence of bodies of water, shading, the sky view factor, the properties of the building surfaces, the albedo, and some variables such as those. So there is a variance that we typically, if we do our typical building energy simulations, we do not actually take into consideration. Most of you are familiar with the notion of urban heat island. It was referred to today as well. The basic idea is that by densely populated cities, especially in the center of the city, due to the number of heat transfer phenomena and the changes, so to speak, anthropogene changes that is done to the natural environment, we get an effect, which means the deviation of the urban thermal conditions from the surrounding rural conditions. There are a number of heat transfer phenomena you're all familiar with. The absorption of shortwave solar radiation, change of albedo, of course, affects that. Presence of impervious surfaces that change the water household of the city, change the evapotranspiration effects, and so on and so forth. Infrared radiation, anthropogenic heat emissions through the transportation industry and heating, cooling, and so on and so forth. As a result, the idea is that if you look at the rural temperature and urban temperatures, you see that there is a phenomenon in which the cities do not cool during the night, the center of the city or the main urban part of the city as they used to do. I mean, absolute agreement with the presentation by Mr. Roulet before about the priority of the passive methods. But if we don't pay this attention to this phenomena, it will be soon the situation that even in Middle Europe, you don't get during the night enough the delta T that you require in order to substantially cool the mass of the building. If you cannot do that, so to speak, you lose a major reservoir of passive cooling technologies, even in Middle Europe. So this is something that we have to take into consideration. Question that has emerged in the last few years, okay, we know about this, we have been talking about this, but to which extent this phenomenon really exists and how serious it is. This was a, so to speak, partial reason for a initiation of a European project. It's called UHI. This is funded by EU, and a number of partners participated in Central Europe to address the extent of the urban heat island phenomena in Central Europe and to reflect about possible adaptation mitigation measures and think about what are the tools that are at disposal for the municipalities and planners to address this phenomenon. So I think it has a major implications also for the people involved in the building industry. So this is just a list of the municipalities that are involved. There are 7, 8 cities across Central Europe, and both scientific community and the municipalities participated in the project. To show you some of the results, we did an assessment over these 7, 8 cities here, just some examples from Vienna, Modena, and Warsaw, 3 cities in Central Europe, typical summer day, and you see the difference always between the urban temperature and the rural temperature. And you see that more or less in all cities, a major difference exists, especially the nighttime. The differences can be quite dramatic, as you can see, for example, in the case of Warsaw. Another way to look at it is using the indicator of urban heat island intensity. Urban heat island intensity is simply the difference between the rural and urban temperature. As many indicators is also kind of an issue of to which extent really is expressive of the phenomena, because your selection of the urban locations of temperature measurements and the rural locations of measurements affect that. So it's a little bit of a statistical issue of how we define that. There are also colleagues, Stuart Oke, that suggest, for example, that we should use other indicators of urban heat island intensity. I don't want to go so much into this, so to speak, technical discussion. Let's take this difference simply as one indicator. And if you look at it across a typical summer day again, you see here the differences. So 0 would mean that there would be no difference between the rural and urban temperature, and positive difference mean that the urban temperature is higher, as you see, especially during the night times. The urban temperatures in all of the cities that we looked at are higher. Sometimes in some cities during the day you might get actually a somewhat lower temperature than the rural temperature during the day. So these are the results for various. As you see, in some of them, the conditions are fairly dramatic. Some of them have already started to address that with certain measures, including, for example, green roofs or increased vegetations, or reduction of the dominance of the transportation, so to speak, in the life of the city. Those are some of the, if you want, mitigations measures that have been considered. Yet another way which I find interesting to look at this data is in terms of a cumulative distribution function, frequency distribution, and here is the UHI intensity. It is a question if when you get, so to speak, the alarm signal, if the 3 degree Kelvin is that or not. It really doesn't matter so much, but you can see that, for example, if we look 3 degree Kelvin as urban heat island intensity, you see that almost in all of the cities, some percentage of the time, in Warsaw about 50%, for example, in Vienna it is about 95%, that the urban heat island is below that, or if you could say is 5% above that. So in most of the cities, we have at least somewhere between 10 and 20% of the time this measure of urban heat island intensity, so to speak, transcended, which is something that has to be addressed. In the framework of the project, we said, okay, it is, so to speak, established that this phenomenon exists. It is established that it is significant. But what are the possibilities, and especially what can the municipality exists such a tradition of having formulated approaches and having formulated those approaches from the EU down to individual countries to address that. So it's a kind of a task of the current scientists to address those. One schema that we propose within the framework of these projects that we could go about this by addressing, for example, a certain area of an urban context. We call it an urban unit of observation. Define that area in which, for example, you are contemplating to invoke mitigation measures, to specify that in terms of a number of variables, and consider the mitigation measures that you are projecting in terms of changes of those variables. We suggested to think about it that way to make this discussion about the mitigation measures somewhat more specific and possibly quantifiable. So that is a challenge that we tried through this proposal to address. Once we have this shift of the measurable things that we can do to a relatively large unit of urban fabric, then we could go about and think about in which way can we project the effect of those measures. In case of buildings, as you see today, and you see in many conferences, not only ASHE, everywhere, in case of individual buildings, we have now the tools at our disposal to project what if kind of scenarios, what would happen if we improve the insulation, or if we do something about the systems, or change the glazing, and so on and so forth. When we talk about an urban unit of observation, that is somewhat more complex to if you permit me an understatement. So here, just to show you the example of this process, we took here a little part of, in the city of Vienna, in the central part of the city of Vienna, we relatively dense, and we look at it as an urban unit of observation, and we define, so to speak, the salient variables where we think or suspect variables, or so to speak, potential variables which constitute the problem and can also address the problem. I will not go all of that in detail because it will take some time, but you see, for example, factors such as sky view factor. What percentage of the sky is actually visible from a point of view in terms of the short-wave radiation incidence and in terms of the infrared back radiation during the nighttime? What is the aspect ratio of the streets? What fraction of the urban city is actually built? What fraction of it is unbuilt? And what fraction of the unbuilt is actually impervious versus pervious? What is the green area fraction and bare soil fraction? What is the mean building compactness and also some, so to speak, semantic properties? What is the albedo, emissivity of surfaces, thermal conductivity, specific heat capacity, and so on and so forth. So get the main constituents of the characteristics of the urban units of observation in terms of geometry and morphology, and in terms of the semantic properties, physical properties, plus some information about the transportation, vehicles, and the anthropogenic heat emission due to the buildings and industry, and so on and so forth. Once we have a grasp of this, if you want, you can represent this in a GIS kind of based system. Here is just for visualization. This is the distribution of the sky view factor for this location. You see the brighter parts are locations with large sky view factors, and the dark parts are the ones with the small view factors. And we think that this type of information can be part of a building information model at the level of the urban, at the GIS-based level. Now, once you have that type of basic, so to speak, unit of observation, you can contemplate different mitigation scenarios. And with these groups of our colleagues in these cities, we composed such measures together with the municipalities of, for example, looking at possibilities of planting trees, having green roofs, or introducing, for example, cool walls and water bodies, and so on and so forth. So each of the participating cities conceived a number of scenarios that they deemed kind of possible and realistic, and we, so to speak, represented those. This is an example of Vienna, for example, trees, green roofs, or a combination thereof. And we represented those mitigation measures, as I mentioned before, the changes in the relevant variables of the urban unit of observation. For example, the sky view factors, what these scenarios would do if we would make these type of changes. So having a, so to speak, formal, rigorous way of reflecting potential projected changes into this unit of observation. You can also show it in terms of these type of differentials. If you want to have a better visualization, you could see, for example, how the base case could be manipulated through different measures and how you can represent those changes in a way that is visually more easy, processable as opposed to tables. So these are, for example, for Vienna, and you see this is for the Padua. The colleagues came up with a number of alternatives or options that they wanted to explore, and this is another one from Modena, different measures and how they, at this would impact the values of the variables of the urban unit of observation. Once we had these multiple scenarios and their, so to speak, representations, we could contemplate different type of models. Of course, we could also talk quite a lot. There are different approaches to modeling. Some of those are based on basically extended numeric simulation involving, for example, computational fluid dynamics and so on and so forth, with the caveat that they are fairly difficult to use, fairly slow. But it seems to me that that is one of the viable options that in future will become more, so to speak, amenable for parametric studies. When we went through a, so to speak, process with all the partners, most of them decided for these type of modeling studies that would give them things like, for example, this temperature distribution in the micro scale as a function of different measures, or they look at, for example, thermal comfort implications of such measures. We could attempt to model those. I mentioned the issue of energy, but obviously the urban heat island affects also significantly the outdoor thermal comfort of the occupants of the city. If you think about heat waves, one of the problems of climate change and urban heat island is not only that you get an increase in the average temperatures, but in the increase in the number of days with extreme temperatures. Even in average, you could live without cooling system. The problem is that if you have these recurrent heat waves, that this will, so to speak, encourage people to install cooling aggregates because of those very extreme situations. And there are people who come and even make arguments on that based on the issue of health and so on and so forth. Most of the people use the available applications called EinB and use that application, which is a CFD-based numeric calculation, which allows to model in fairly simplified way the physical fabric of the urban context and then calculate certain things like airflow and temperatures. One idea is how would we represent the results. The way we, for example, one of the result is, of course, classically look at what happens to a typical reference state temperature. If you do a certain measure, what happens to the urban heat island intensity if you do the measures, or simply for a reference day, look at the potential in terms of Kelvin hours and say if I would, for example, plant trees, what reduction of cooling hours would I achieve if I would do green roofs, what level of cooling reduction would I achieve in terms of Kelvin hours, or if I do a combination of those. These are some results for the Vienna. These are some results for Padua. You see these measures, cool roofs and green areas, and you see again the impact on urban heat island intensity and the reduction of cooling potential or cooling need. Another example for Modena, the respective results. So I think it's a first systematic approach to capture the existing situation in part of a city, to express the existing city in terms of some rigorous, measurable values and variables, conceive possible improvement measures in terms of measures such as vegetations and water and so on, or for example changing the traffic conditions, and then use modeling techniques in order to estimate the effect of those. As I mentioned to you before, one thing that was of interest, I'm a great fan of modeling, so to speak, at the same time very skeptic of purely modeling-based assessment, because you have compared, for example, real energy requirements of buildings with simulated one, you've noticed that there are a number of uncertainties involved. A good simulation specialist would never give people one number and say that's going to happen, but would always express an uncertainty, for example, as you heard today, as a function of occupants' behavior and things like that. So I would like to look at these type of modelings that we conduct also in the context of possibility of saying what are actually empirical possibilities that at least allow us to partially validate these models, and we see what is the range of that uncertainty. To address that, something that occurred to us, a very interesting observation, is when you arrange this variable in a certain way, you see that the improvement results tend to, so to speak, collect themselves on one or the other side, which it basically says that certain variables have predictable urban heat island intensity. So we went and looked at
5 minutes remaining, Mr. Mahdavi.
We looked at the city of Vienna, and we looked at a number of positions where we have detailed data of microclimatic conditions, and we said, let's do this study, this morphological study of how conditions around these measurement points are, and let's express them in terms of the value of these variables and see if we can get certain relationships. And we are, so to speak, in the beginning of this process. Here you see, for example, the features of different areas that I showed here before. So these are these points of measurements in the city of Vienna, and these are the, so to speak, characteristics of the urban fabric in this area. You see there is a gradation. So we followed this gradation, and we find a certain interesting relationship, for example, between the sky view factor and the urban heat island intensity, between the impervious surface fraction and the urban heat island intensity, anthropogenic heat output, the built surface fraction and urban heat island intensity. And I remind you that they're actually fairly intuitive. I mean, if you think about why the local macroclimate, I think you would be able to kind of explain that based on that. So we are following those empirically based indications to develop, parallel to the numeric method, some simpler empirically based methods, which would make it easier also for the municipalities, because that's the questions that they always ask. Does it bring, if I do a certain measure, it costs a lot, and so on and so forth? What is the scope of the benefits that I would get? With these methods, we would have some more confidence beyond the numeric, some numbers on those expectations. So, putting that together, I think we are on the verge of a situation that we should stop talking about individual buildings in terms of the solution of the energy efficiency. We should stop talking about individual technologies as, so to speak, panacea for the overall energy efficiency problem. We really have to look at the urban realm and look at the connections of the buildings, transportations, recreational quality of the city, and those type of issues. Thank you.
Και να έχουμε τις ερωτήσεις.
Thank you. Rapsomanikis from University of Thrace, Democritus University. 2009, we made a study about UHI, The project is called Thermopolis 2009. It was funded by ESA. There's 50 gigabytes of data about Athens at that time. We did a different approach to what you were doing, and we still have a Met Tower in the middle of Athens, measuring energy fluxes for a footprint which we have defined is representative of Athens. We looked also at satellite infrared emissions from Athens. And we defined UHI in Athens during nighttime concerning the difference in temperature. For example, the Marathon Lake temperature and the center of Athens temperature, is a difference between 8 and 10 degrees. And we came at some very serious problems in defining the flux. And I don't think anybody in the scientific community can say that they have defined the anthropogenic heat flux on the energy balance equation. Hence, our approach to this mitigating the urban heat island, at least in Athens, is threefold. We cannot, with great certainty, say anything about applying infrared data to Athens. We defined this problem by having flights from the CASA people in Spain and from our plane, that the satellites never give us the true temperature because of the angle that the satellites look at Athens. And the second problem we found is that using trees and having a similar study with our colleagues in Lancaster, we could not come up with the trees that we would like to have in Athens that would do three things: cool, pick up and pick up particulate matter that we would like to lower down in Athens. Hence, I find that there's a lot of research to be done on this field, and we are looking at it from the micrometeorological point of view, from our tower and from our planes. And the good thing about Athens is that it's more or less, it's a homogeneous field as far as micrometeorology is concerned. We use the ARM model, but even for the footprint that we're trying to look, we are not anywhere near in getting data and models to agree. My question is, do you believe that the ground level stations are a better approach to the micrometeorology fetch idea that we use together with our Helsinki colleagues?
I was hoping that the question is at the end of this long lecture. Thank you very much. The results that I talked about and what I presented to you is all based on ground level observations. I'm aware of the work that has been done in Greece. I thought, since I'm a guest and I'm talking about a EU project, I don't need to talk about that. I'm sure you can take care of that.
We thank you for your presentation. I am a student at the School of Civil Engineering at National Technical University of Athens. And I would like to ask you if programs like EinB that simulates urban microclimate are reliable, and if you think that these programs are better to use in order to compare different scenarios.
That's an excellent question. I think the answer that I give to you is, I'm afraid, a little bit a cliche answer. Is the same kind of answer that I would give you if you would ask me about ESPR or Energy Plus or other energy simulation program. The additional problem is that we are here, I believe, in this field about 20 years before as where we are right now with the energy simulation tools. It's the same. We did a couple of experiments of looking at, for example, the colleagues here in these 7 cities using different versions of EinB. And the results were somewhat different. Also, if you give the same tool to 5 different experts, you get, in many cases, very different results. So that's why I'm careful by saying that it is possible to get consistent and so to speak, rigorous results simply by using a tool, no matter how solid the tool itself is. You need the combination of an expert who knows what the phenomena are. You need some empirical underpinning. I think that's very important. And you need the tool. You need all these 3 components to make something, to make some sensible statements based on. Just so that in a lot of cases the municipalities kind of force the engineers in a corner and say, tell us objectively what can I expect from doing this investment. And the combination of empirical results, modeling results give us a kind of confidence to make a statement. I hope that answers at least partially your question. Thank you. Thank you very much. Okay.